This is a center tapped potentiometer, and 4-lug potentiometers are pretty common in old hi-fi equipment. And that 4th lug is often referred to as a loudness tap. Now, this one started off as a stacked concentric pot taken from my 1977 Chevy pickup truck, and the tone pot wafer was broken. One of the lugs was missing, and I wanted to rescue the wafer for the volume control and do some experiments with it. For the new housing, I used a donor pot made by Alpha. They were about the same size, and it looked like it would be a pretty easy task to disassemble everything, change the wafer over, and put the new housing around that old 4-lug wafer. First step for me was to disassemble the concentric pot by bending back the metal tabs, and that allowed me to remove the metal collar and then the nylon post with the broken tone pot wafer. Under that, the metal can around the tone pot, I was able to bend back 4 more metal tabs and then pry off the backing. Comparing the volume pot to the Alpha, they're sized about right. They have the same tabs, the same locations, and I will need to modify the backing for that 4th lug. Bending back 4 more metal tabs, I was able to remove the back and lift off the wafer and set the backing with the switch in it aside. Okay, so now I can inspect the carbon trace. You can see where the tap is coming off. And I've got that raised center ring in the middle for the wiper. I probably won't need that metal spacer. I'll set him aside. Over on the Alpha pots, I have a 250K and a 1 meg pot to choose from. Somehow the 1 meg pot didn't get a stamp at the factory, so he's going to be my donor pot. Similar disassembly, bending back 4 metal tabs, I was able to open the pot and lift the wafer with the shaft and the wiper all together. I didn't expect that, so I'm going to inspect and think maybe I can remove the metal from the shaft, or probably have to just pry off that disc for the wiper. And with that done, I can inspect the trace and test fit the old wafer in the new housing just to see if it'll fit. Okay, so the hole going through the wafer is too small. I'll have to address that. And the metal around the shaft has some extra metal tabs. I'll have to remove those or make room on the wafer for them. The hole in the wafer was a little bit too small. It's almost 11/32 of an inch. I used a stepper bit to remount that hole so that the metal shaft would fit. The metal tabs around the base are easily removed with a pair of wire cutters. Replacing the disc for the wiper back on the shaft, I just tried to press it on with my thumb and then press it a little bit more firmly into place using a pair of needle nose. To make room for the 4th tab, I used the wire snips and cut a couple of notches, and then just brute force bent it back with the needle nose pliers. So pressing everything back together and holding the backing in place with the metal tabs, it looks really good. Let's test it with the ohmmeter.
All right, so there it is.
Connecting the outer lugs, pretty good right at the top, 20.93K, but otherwise no. Moving the wiper shows an open circuit. So opening all that back up and testing with the ohmmeter again, Okay, it works if I press the wiper onto the wafer, but it's sticking at the 9 o'clock, 12, and 3 o'clock positions. I'll have to pry off the disc again. Yeah, the raised metal ring and the smaller center is catching. So I consider modifying the ring, but no, I really don't want to risk damaging the wafer for the sake of that. Taking a look on the wiper though, there's a redundant wiper on the outside and it's getting in the way. After some careful thought, I decided to snip out that outer wiper and clean that up. Press things back down and out of the way and reassemble. Putting the wiper back in, I first pressed it in place. And then gave it a few taps with a small hammer and a socket. And that was a perfect fit. So reassemble, putting the back on and testing again. Right off the bat, 5.6K. Sweeping around. It's behaving like a logarithmic pot. So it's got an audio taper. And the tap is at about 6K or so. 6K. Here's an interesting test from the wiper to the tap. Moving around, I should see the resistance decrease to near zero at the tap, and then it'll start going back up. Okay, so there you have it. Now, I have a project coming up that's using this repurposed volume knob. I've also got some LT Spice analysis and some simulations that I'm doing with these kinds of circuits. If you're interested in seeing that analysis and seeing the circuit that this thing is going to become a part of, do consider subscribing to the channel because I'd love to see you come along and see that part. I look forward to seeing you guys there.